Let's talk about graphing linear inequalities. As you know, y equals mx plus b is the equation of a line. This is an equation of a line because you see an equal sign. M, which is the number that's next to the x when the y is by itself, is your slope. Your slope is your rise over run. And b is your y-intercept. So we're going to be doing exactly the same thing, except that we're going to be looking at inequalities. So our problems are going to look like this. Y is less than or equal to 3x minus 2. Notice it looks very similar to y equals mx plus b. My slope is 3. My y-intercept is negative 2. And of course, the y is by itself. So I'm going to go to negative 2, which is my y-intercept. I'm going to go up 3 over 1 because that's my slope. So from negative 2, you go up 1, 2, 3 over 1, up 1, 2, 3 over 1. But then before you draw a line, you have to look at the inequality. If it's less than or equal to, greater than or equal to, that is when you're going to draw a solid line. Okay, so it's going to be a solid line. But if it's less than or greater than, you're going to have a dotted line. In this particular case, for this problem, I have y is less than or equal to, which means that I'm going to actually connect these with a solid line. So now that I drew my solid line, so which way am I going to shade? Because it says less than or equal to, and I have the y completely by itself on the left-hand side, I'm going to shade below the line. So I'm going to shade everything below this line. And if you have colored pencils, then you can shade. So basically all of this is going to be part of my answer, all up until I get to this line. So there's infinitely many points that are going to be here. Another way that you can tell which direction you're going to shade is to test the point 0, 0. Okay, when you test the point 0, 0, if it holds true, you're going to shade wherever 0, 0 is located. But if it doesn't hold true, then you don't shade it. So in this particular case, if I do this test, I'm going to replace the y with 0. So 0 should be less than or equal to 3 times 0 minus 2. So 3 times 0 is 0. And the question becomes, is 0 less than or equal to negative 2? And the answer is false. Okay, 0 is not less than or equal to negative 2. Therefore, here is 0, 0. I'm not going to shade where 0, 0 is located. I'll shade everything else instead, which is the stuff that we had already shaded in red. So yes, we have done this problem correctly. And so one of the ways that you can do this is to just test the point 0, 0. Let's try another problem. So let's take a look at the screen in front of you. It says negative 4x is greater than 16. In this case, I have no y at all. I don't know if you remember, but when you have an x only and you don't have a y, that means that we have a vertical line. In order for me to graph this vertical line, I'm going to have to get the x by itself. So I'm going to divide both sides by negative 4. When I divide both sides by negative 4, the inequality is going to have to change. The inequality only changes when you multiply or divide by a negative number. So I get x is less than negative 4. Here, I'm going to have to use a dotted line because if you remember, less than or greater than is a dotted line. So I'm going to go to negative 4 and I'm going to create a dotted line. And because it's less than, I want everything that's less than negative 4, I'm going to shade everything to the left. And so this is how you're going to graph this problem. In this next problem, we have 4x minus 3y is greater than negative 12. Before I can actually graph it, I'm going to have to first get the y by itself. So I'm going to subtract 4x from both sides. When I do so, the inequality does not change because I'm not dividing right now by a negative number or multiplying by a negative number. I just subtracted. But now when I'm going to go ahead and divide everything by negative 3, this is when now I am going to have to switch the inequality because I divided by a negative. Negative 4 divided by negative 3 is positive 4/3 x. Negative 12 divided by negative 3 is a positive 4. So on my graph, first I'm going to locate positive 4. and I'm going to put a point because that's the y-intercept. Notice the slope is 4/3, which means I go up 4/3. And in this case, going up 4/3, I'm going to run out of room in my graph. Going up and over is the same as coming down and left. So if you remember right here from the very beginning, we had said we had -4 over -3. That means down 4, left 3. Down and left is the same as up and right. So here I'm going to go down from the +4, 1, 2, 3, 4, and then left 1, 2, 3. So this is how I'm going to graph this. Remember to stop and think, is it dotted or solid? In this case, it's going to be a dotted line. And then you have to ask if you're going to shade above or below. As long as the y is on the left-hand side, here it says less than. So that means that I'm going to shade below the line. So I'm going to shade everything here that's below the line. And that's going to be my answer. Before we do the next example, just to recap, if we have less than or greater than, that means that we're going to have a dotted line. If we have less than or equal to, greater than or equal to, we have a solid line. As long as the y is on the left-hand side, if it's y less than or y less than or equal to, that means I'm going to shade below the line. And if it's y greater than or y greater than or equal to, you're going to shade above the line. And below and above all depend on which direction the line is going. So a line could either be increasing because it has a positive slope. It could be decreasing because it has a negative slope. It could be a horizontal line because the slope is 0, or it could be a vertical line where the slope is undefined. So we have above, 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 above or greater than, okay? And then we have everything else would be below. So depending on which way the line is going, this would be either above or below. So that is basically like a summary of what it is that we're doing in terms of graphing. And again, this idea of shading above and below is helpful if you don't want to test the point 0, 0. Testing the point 0, 0 is always going to help you figure out where you're going to be shading. This applies for the shading above or below as long as the y is on the left-hand side. If the y is not on the left-hand side, then you can't apply this. So let's go ahead and take a look at this problem. We have -2 minus 4x is less than or equal to 2y. Notice that the y is almost by itself, except that we have to get rid of the 2. So I'm going to go ahead and divide the entire inequality by 2. So when I divide by +2, it does not change the direction of the inequality. You only change it when you multiply or divide by a negative number. So we have -1 minus 2x is less than or equal to y. So if you want to apply what I just shared with you about shading above or below, you're going to have to flip this entire inequality around. So I'm going to completely kind of like mirror image this so that I flip it around and I have it written as y is greater than or equal to -2x minus 1. Okay, so I completely flipped it. So now the y is going to be on the left-hand side. So if I go to my graph, the y-intercept is -1. The slope is to go down 2 over 1, which is the same as going up 2 left 1. The line you're going to draw in this case is going to be a nice solid line. And then because it's greater than or equal to and the y is on the left-hand side, then I can go and shade above the line. So basically everything above the line is going to be my answer. So that is exactly how you're going to graph this linear inequality. I hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.